Okay, so in our new unit, we are going to be talking about polynomials is our overall unit. But before we can really dive into polynomials and do some more things, we need to know our basic rules and properties of exponents. Okay, so good news, properties of exponents, which our quiz is going to be over on Thursday, are really simple. Bad news, when we put them all together, it's really easy to confuse yourself because the properties don't meet any of the normal rules that we would normally talk about in math. Okay guys, so I know we're back from break, but rules are still the same, so headphones need to be put out, devices need to be put away. Okay, so before we can even really dive in, let's make sure that we know some terminology that we need to be able to talk about. So if we have something, okay, that is receiving an exponent that also has a number sitting in front, we want to make sure that we know the words we would use to talk about these things. Okay, so this B up here, this tiny number that sits up at the top, what do we call this?
A B.
Exponent.
An exponent, right? This is our exponent. What does an exponent tell us to do? So like if I said 5 squared,
5 times 5.
right? It tells us to multiply the big number by itself a certain number of times, right? So the big number, this number here, what is this called?
Variable.
I mean, it is a variable in this situation, but it doesn't always have to be a variable. This is called our base. Okay, so the base is going to be whatever is receiving the exponent. Okay, we're going to start off with that base being a variable, but that's not always going to be the case. The base can be a number. Okay, and then we also have the number that could potentially be sitting in front. Do we know what this one's called? We use this word a lot.
Number.
It starts with a C, something.
Constant.
Coefficient.
Coefficient.
Yeah.
Okay, so the coefficient is the number sitting in front of the variable. Okay, it is important to understand when we are looking at this unit that the coefficient, the number in front, is going to have the same rules it has always had. You know what to do with coefficients. You have been dealing with them for several years, whether you know it or not. Right? You've had an equation with 4x plus 2x, and you've turned that into a 6x. So you cannot let the rules that we are going to start looking at affect the rules that you already know to be true. Okay, so when we are talking today, we are going to be focusing on what we do if there is a small number or an exponent, and what then happens with that exponent. Okay, you cannot forget everything you've ever learned in math. And that's the hard part in this unit. It's hard to not get that stuff confused when we're learning the new stuff. So the first property that we're going to look at with exponents is we can add and subtract with them. You have been adding and subtracting with exponents for forever. Because the deal is that everything has an exponent. Sometimes we're lazy and we don't write it. So just like if we were to talk about the variable x, what number is sitting in front of this x?
1.
A 1. It has a coefficient of 1, even if we don't see it. That same thing is true for an exponent. This x has an exponent of 1, even if we don't see it. Okay, so you have been dealing with exponents, whether you know it or not. So you've been doing things like 2x plus 4x and getting an answer of what? 6x. How did we get an answer of 6x? We added, right? We have a coefficient of 2. We have a coefficient of 4. So if I have 2 x's and then I have 4 more x's, altogether I have 6 x's. Okay, that same thing is true regardless of what happens with the exponent. So if I now say something like 2x to the third plus 4x to the third, what do we think would make sense for an answer to be? What did we do up here? How did we get this 6? We added what? The coefficients, the 2 and the 4. So what do we think we should do here? Add the coefficients. So what is 2 plus 4? 6. And then what do we think we should do with those x to the thirds?
72.
Adam.
That's the answer.
What was it? What was the exponent right here?
1.
And what was the exponent right here?
1.
And what did we end up with an exponent of?
1.
So if this is a 3 and this is a 3, what should we end up with? 3.
Huh?
Wait, I'm confused. If there's a exponent, aren't you supposed to do like 2 times 2 times 2?
This exponent isn't on the 2, this exponent is on the x. Good question. Nope, this is just adding, right? 2x plus 4x is 6x. 2x to the third plus 4x to the third is 6x to the third.
She's confused.
Okay, if I have 2 x's to the third, and I have 4 more x's to the third, how many x's to the thirds do I have? 6 of them.
Yeah, 6.
Does that make sense?
Yeah.
Okay, so how about 5y to the 7th minus 8y to the 7th?
Negative.
-3, because we're taking 5 minus 3.
Y to the 7.
And our label staying the same? Okay, so our property rule, our rule when we are adding with exponents, says that we are going to add or subtract the coefficient, that big number in front. Why? Because that's what we've always done, right? 2 plus 4 is 6. Coefficients function under the math rule we have always known. 5 minus 8 is -3. Okay, so we're going to add or subtract the coefficient, whatever the sign is, and we are going to keep the exponent the same. Now, I always tell my students this is kind of like a car commercial, where at the end there's all that really tiny fine print. Okay, so this does come with kind of tiny fine print, but it's tiny fine print that should make sense to us. This only works if the base and exponent are the same to start with. Which hopefully makes sense to us because, class, I would never say to you what is 2y plus 4x and then you turn it into 6 something, right? We can't do that. That just in our brains is like, yeah, duh, we've never been able to do that, so why would we be able to do that now? Then there's nothing you can do with it. Okay, so if we were to say 5x to the third plus 7x squared, that just stays as this. You can't do anything. It just stays as 5x to the third plus 7x squared. There's nothing else you can do. It is simplified. students look at that and they're like, sweet, right? That's pretty straightforward. Nothing very complicated. Like literally, you can pick up your calculator and do 5 minus 8 equals -3, and then write down the same label.
That's all we're gonna do?
Yeah, yes. Like I have no tricks up my sleeve, that is literally it.
No, it's not.
Yeah, it absolutely is.
Alright, now we gotta do 3/4.
No,
Plus 2 equals 1 minus 2.
I know. This is it. This is it for adding and subtracting.
And we gotta take a test over this?
Well, you're going to take a quiz over this.
Okay.
But there's more properties to add. So next property, okay,
5 plus 3. Add 2.
is we can multiply with exponents. Like I said, I mean, the good news about this chat, like literally the properties are very, very basic. Okay, I have no magical tricks up my sleeve. The problem is that the properties aren't normal for what we normally think. Okay, and you'll sort of see here what I mean as we go on a little bit. So what happens now if instead of adding, I want to multiply? So what happens now if I have x squared times x to the third?
X times x times x times x times x.
Okay, so x squared is now an x receiving an exponent of 2. And do we agree that an exponent of 2 says multiply it times itself? So x squared is really x times x. Agreed? Oh. And x to the third is really x times x times x. Just trust me for 1 second, Jordan.
Jordan.
Or Jaden. So do I even have a Jordan?
I mean, Michael B. Jordan.
And now we're going to multiply these two things together. I've been asleep for 2 weeks too. My brain's still trying to turn on. Get going. Okay, so what this is really saying is x times x times x times x times x. 5x is being multiplied together, right? And if I'm multiplying something times itself 5 times,
5x.
not 5x, but x to the 5th. Now, that being said, what happens if I have something like y to the 35th times y to the 74th? Are we going to write down y times y times y times y times y times y? I mean, you could, but I would not either. So what does it look like is happening with those exponents? We are adding them.
So why is it multiplied?
Yeah, that's the trick.
You said you had no tricks.
That's the trick.
Mm-hmm.
It's simple. It's simple when you know them, but it's not the normal rule we're used to thinking. Okay, so when we are multiplying with exponents, you are still going to multiply any coefficients because the numbers in front function like they always have. Okay, but we are going to add the exponents. And this is the part where I was saying none of these on their own are hard. My students absolutely can do 50 of these in a row and be fine. It's that when they get all mixed together, keeping this sort of weird, like I'm multiplying some and adding some, like it's weird. It's weird. Okay, now this also comes with a small disclaimer. We can only add exponents if their base matches. Okay, so let's say I want to multiply x to the 12 negative 3. I'm multiplying, so what did I say I would do with those exponents? Add them. So what is 12 plus negative 3?
Negative 9.
Not negative 9, but positive 9. Right? So x to the 9. I mean, right? You could pick up your calculator and type in 9 plus negative, or 12 plus negative 3 if you needed to. And you would get out 9. So now how about 3y to the 4th times 2y to the 5th? Okay, so what are we going to do with the coefficients in front? Multiply them because they function like they always have. 3 times 2 is?
5.
6. And that's the problem. Right? Duh. It's like, duh, we know 3 times 2 is 6, but your brain is already starting to go, well, what do I need to do with these two numbers? Add them. And so then our brain tricks itself a little bit. Now we'll do y. 4 plus 5 is 9. It's not hard. We just sort of have to keep them into those clean-cut categories, right? We're still going, guys. We're not backing up. One of the best things about exponents is that they might get long, but they do not ever get hard.
That's what she said.
Okay?
Sorry,
No. Jaden,
Sorry.
come talk to me after class.
Okay.
So when we look at this problem, it is going to take us more time to do it. Okay, but there's nothing about it that is going to be challenging. We are still breaking it down into the pieces, which means the coefficients are still going to be getting multiplied. Okay, so 6 times 3 times 5.
19.
So I would do 6 times 5 first. What's 6 times 5? 30. 30 times 3 is 90. Then we're just going to go through and do the ones with the matching exponents. Okay, so x squared times x is?
2x squared.
Just the exponents. What do we do with the exponents? Add them. So 2 plus, what exponent did we say was here? 1. So 2 plus 1 is? 3, and we'll get x to the 3rd. Then we'll do our y's. 2 plus 1 is? 3. And so our answer is 90x to the 3rd, y to the 3rd. The last property we're going to add today is what happens when we have an exponent to an exponent. What happens when we have 2 powers at the same time? Okay, so if we have 2 powers at the same time, what is that outside exponent telling us to do? What does this exponent of 3 say?
Multiply.
Multiply whatever I'm covering up by itself 3 times. Right? So I'm taking x squared times x squared times x squared. Okay, and so we'll add the exponents because when we multiply, we add.
X to the 6th power.
And so what does it look like is happening right here? We are multiplying. So when we have an exponent to an exponent, here's the tricky part. I don't have a better word here. We are going to give the exponent to the coefficient. And then multiply the exponents. Okay, so the bell's getting ready to ring here in a minute, but if we have this, we're going to give the exponent of 2 to the 3. We are not multiplying those two numbers, so what is 3 squared? What is 3 squared? 9. And then we'll multiply the exponents. Okay, so that 3 squared gives us 9, and then we'll multiply here, and we'll get 9y to the 8th. Okay, we're going to talk about this more tomorrow.